On June 14, 1988, at 8:30 a.m., the type certificate for Starship was signed and a new epic in the history of aviation was begun. For all who had worked for this day, it was a moment of high drama. No other general aviation airplane in modern times has created so much excitement and anticipation among so many people in so many places. And no other airplane has introduced so many advanced design concepts and technological achievements all at one time. In one great thrust forward, Starship has reached out and changed today into tomorrow. It has shown the way to make the best of modern technology available, and to make it available now. Today, the Starship Design Development Program is essentially over, and the work of converting the major program effort into a smooth and efficient manufacturing system is virtually complete. Now the stage is set to make Starship a practical reality for aircraft operators all around the world. A new 11-acre plant is now fully equipped with production machines, tools, and testing facilities. It's the high-tech nest from which all future Starships will fly. The plant's major mission is to produce a steady stream of Starships, from start to finish, all under one roof. Just as there is no other airplane like Starship, there is no other aircraft production facility quite like this one. Inside, there's a brand new world of computer-controlled pattern makers and cutters. A huge environmentally conditioned clean room. One of the largest autoclaves ever installed. New space-age robotic test machines. And enormous tools and fixtures, especially designed to hold the largest single parts ever seen in general aviation. But old hands will notice something else. It's a world without rivets. Here is where the work of fabricating and assembling the only all-composite business airplane in the world begins and ends. The journey for each new Starship commences in a refrigerated storage room. The pre-preg graphite, from which much of Starship is fashioned, is a simple roll of cloth, woven from graphite fibers and impregnated with epoxy. This basic material is destined to become the parts from which the entire aerodynamic structure of Starship is assembled. Approximately 2,600 parts are used in Starship, significantly fewer than the number required in traditional metal construction. The process for manufacturing virtually all of these parts begins here, in the shaping and cutting of exact mylar patterns, laid over and into the exact contours of individual tools. From these patterns, the Command 1000 computer system digitizes the precise configuration of each ply of each part, converting the shape to numerical data to be stored on magnetic tapes for use on the Gerber cutter. This automated marvel cuts each ply for the individual part, labels it, and adds it to the other plies to make up a complete kit, ready for layup. The steadily accelerating buildup in production now calls for 2 shifts on the cutting operation. 2 tables permit both cutting and labeling to be carried on at the same time, and as many as 40 kits per shift flow into the production sequence. As the rate of production continues to intensify, new layup workstations have been manned, filling a large area beyond the cutting area. Now, more and more skilled hands peel away the protective backing and place one ply on top of another, smoothing and pressing them down in a series of coordinated, sculptural-like motions, molding it tightly over the convex and into the concave areas of the tool. The detailed parts can be small enough to be held in one hand, or as large as the upper or lower half of an entire wing, or a complete fuselage half-shell. Beyond the tables and the cradles where the layup is done, the completed fuselage half-shells are joined together. The upper and lower wing skins are each one piece, 54-foot-long detailed parts which will be sent to cure in the cavernous chamber of one of the world's largest autoclaves. Here we see the upper wing skin, the largest single part ever used in a general aviation airplane. It is being inserted into the mouth of the 60-foot-long, 25-foot diameter computer-controlled machine. Through a combination of pressure and heat, the autoclave compacts and cures the once soft parts. It transforms them into a rigid substance much lighter than metal parts of equal strength could ever be. On the average, Parts will be in the autoclave from 90 to 120 minutes, subjected to temperatures of 300 degrees and pressures of 4.5 to 8.5 pounds per square inch. After the cure, the structural parts will undergo non-destructive testing in the most sophisticated C-scan equipment in the world. Here, for example, we see the main fuselage section of Starship as it both spins and moves forward in a sort of corkscrew motion on its way past each of the 8 fixed probes on the giant linear scanner. Each of the probes produces a high-pressure water jet, which strikes the assembly on opposite sides at precisely the same spot, transmitting sound waves to a computer screen where they are interpreted by a certified technician, after which the results become a part of each Starship's quality assurance record. The inspection grid on the linear scanner is set up to provide about 65 water jet firings on each square inch of the assembly's surface. In all, there will be about 2 million ultrasonic firings on the main fuselage assembly alone. Several million more firings will be used in scanning the tail and nose assemblies. The wing scanner is set up for an even greater concentration of ultrasonic signals. The incredible number of signals used to inspect all the way through Starship's composite skin and the state-of-the-art equipment designed especially to do the job is clear evidence that Starship is, without question, the most thoroughly tested general aviation aircraft ever produced. After the cured parts are tested, cut, drilled, trimmed, and bonded with other parts, they move on in a continuous buildup to become major assemblies. Today, the area assigned for final assembly stretches almost all the way across the north and south dimensions of Plant 3. The Starship production pipeline is filling up. Almost 300 skilled and dedicated Starship manufacturing personnel have been carefully chosen, trained, and integrated into work groups. Today, morale is high. With a plant rapidly flashing out with people and equipment and materials, and a pipeline filling up with parts and sub-assemblies and assembled airplanes, the Beechcrafters working on Starship are keenly aware of the importance of the pioneering role they are playing in the history of aviation. The Starship Type Certificate taped to the nose of NC-4 tells the story best. This Starship, like all the ones that will follow, represents the shape of things to come. It's the airplane certified to make history.